I am Mr. Singaya, Faculty of Mathematics. Today I am going to explain the concepts of circles. Find the equation of the circle with the center -2, 3, cutting a chord of length 2 units on 3x plus 4y plus 4 is equal to 0. Here, center of the circle is given -2, 3. Equation of this line is given. Actually, it is a non-horizontal, non-vertical line. But to understand the concept, I have taken like this. It is non-horizontal, non-vertical line. Right. It is making 2 units on this line. Length of the chord is 2 units. AB equals to 2 units. Length of this chord is 2 units. So to find the equation of the circle, here we have center. So we require radius. How to do that? Draw a perpendicular from the center to this line. It is the perpendicular bisector of AB. It is the midpoint of AB. Here, length of AB is 2 units. So, AM is equal to 1 unit. Now, finding the perpendicular distance from the center to this line. It is C, center of the circle. CM, that is the perpendicular distance from the center to the line. Perpendicular distance from the center -2, 3 to the given line. (3x plus 4y plus 4 equals to 0 is modulus ax1 plus by1 plus c by square root of a square plus b square. That is 3 into -2 plus 4 into 3 plus c by square root of a square plus b square. It is d. Okay. Now, -6 plus 12 plus 4. Simplify this one, that is 5. 4 plus 12, 16, minus 6, 10. 10 by 5, 2. 4 plus 12, 16. 16 minus 6, 10. 10 by 5 is 2 units. So, perpendicular distance from the center to this line is equal to 2 units. Here we have to find the radius of the circle. It is a right-angled triangle. Applying the concept of Pythagoras theorem. Here in triangle AMC, AC square equals to AM square plus CM square. AM is equal to 1 unit plus CM 2 units. AC is equal to root 5. That is the radius of the circle. Radius of the circle is root 5. Now we have center and radius. Finding the equation to the circle, that is x minus h whole square plus y minus k whole square equals to r square. X minus -2 whole square plus y minus 3 whole square. Radius is equal root 5. X plus 2 whole square plus y minus 3 whole square equals to 5. It is the equation to the required circle. Now expanding it, that is x square plus y square plus 4x minus 6y plus 4 plus 9 minus 5 equals to 0. X square plus y square plus 4x minus 6y, 4 plus 9 13, 13 minus 5 8 equals to 0. Prove that the tangent at the point 3 comma minus 2 of the circle x square plus y square equals to 13 touches the circle x square plus y square plus 2x minus 10y minus 26 is equal to 0 and find its point of contact. First we have to prove that the tangent at this point to this circle touches this circle. That is the first part. And the second part, find the point of contact like this. Here center of the circle is 0 comma 0 and radius is root 13. Here 3 comma minus 2, 3 comma minus 2. Next, the tangent to this circle touches this circle. Its center is minus 1 comma 5. Minus 1 comma 5. Now, here the tangent at this point touches another circle x square plus y square plus 2x minus 10y minus 26 is equal to 0. Like this. It is the point of contact. Okay, how to do this? First, finding the equation to the tangent at this point 3 comma minus 2. Equation to the tangent. Equation to the tangent to the circle x square plus y square equals to 13 at the point 3 comma minus 2 is formula S1 equals to 0. Equation to the tangent formula S1 is equal to 0. That is x1 plus y1 plus g of x plus x1 plus f of y plus y1 plus c equals to 0. Here x1 take this one at the point 3 comma minus 2 x into 3 plus y into minus 2. Here the value of g is 0 in this equation. 0 plus the value of f is also 0. C it is minus 13 equals to 0. That is 3x minus 2y minus 13 equals to 0. Okay. Now we have to prove that this tangent is touching another circle. We have to prove that this line is touching this circle. How to apply that? Now center of this circle is, center of the second circle is x square plus y square plus 2x minus 10y minus 26 is equal to 0. Right. Comparing this equation with x square plus y square plus 2gx plus 2fy plus c is equal to 0. 2g is equal to 2, g is equal to 1, 2f is equal to minus 10, f is equal to minus 5, c is equal to minus 26. Okay. Center, that is minus j comma minus f, that is minus 1 comma 5. Okay. Radius, r is equal to root over g square plus f square minus c. G square 1, f square 25 minus c, that is minus 26. 1 plus 25, 26 plus 26, that is root 52, that is 2 root 13. Okay. Now we have to prove that it is touching the circle. To prove this one, we have to prove r is equal to d. R is equal to d. It means perpendicular distance from the center to this line equals to radius. We have to prove that. That is center of the second circle is minus 1 comma 5 and equation of the tangent is 3x minus 2y minus 13 equals to 0. Now, perpendicular distance from the center to the line 3x minus 2y minus 13 equals to 0. That is mod ax1 plus by1 5 minus 13 by square root of a square plus b square minus 3 minus 10 minus 13 by square root of 3 square 9 plus 4 13. Okay. Here minus 13 minus 13 minus 26 by it is root 13. Okay. Now 26 by root 13, 2 into root 13 into root 13 by root 13. It equals to 2 root 13. It equals to radius of the second circle. The radius of the circle is, second circle is 2 root 13. We got the same one. It means tangent of the first circle like this is touching the second circle like this. Now we have to find the point of contact of this one. Point of contact of this one. It is the common point for the circle and tangent. We have to do that. Here, tangent of the first circle is touching the second circle. First part is over. Now, finding the coordinates of the point of contact. How to do that? Here, assuming the point of contact is x1 comma y1. x1 comma y1. Here, equation of the second circle, that is x square plus y square plus 2x minus 10y minus 26 is equal to 0. And tangent equation 3x minus 2y minus 13 equals to 0. Now we have to find the coordinates of the point of contact. How to do that? Here, let the point of contact be x1 comma y1. Point of contact be x1 comma y1. Equation to the here I am giving it is 3. First one is x square plus y square is equal to 13. First equation, first circle equation. It is second circle, it is the tangent equation. Okay. Equation to the tangent to formula S1 equals to 0. Equation to the tangent formula S1 is equal to 0. That is xx1 plus yy1 plus g of x plus x1 plus f of y plus y1 plus c is equal to 0. Here substituting the values xx1 plus yy1. Here in this equation the value of g is 1 into x plus x1. In this equation minus 5. F is equal to minus 5 into y plus y1 plus c, that is minus 26 is equal to 0. Right? Here xx1 plus yy1 plus x plus x1 minus 5y minus 5y1 minus 26 equals to 0. Now writing this equation in the form of Lx plus my plus n is equal to 0. Lx plus my plus n is equal to 0. Here coefficient of x, take these two. In these two terms, x1 plus 1 into x. Next, coefficient of y, here in these two. That is y1 minus 5 into y. Now write the remaining terms. Here x1 minus 5y1 minus 26 equals to 0. x1 minus 5y1 minus 26 is equal to 0. It is equation number 3. Sorry, here 2, 3, it is 4. See here, these two equations 3 and 4, these two equations represent the same line. 3 and 4, 3 and 4, 3 and 4 represent the same line, represent the same line. These two equations, this equation and this equation, these two equations represent the same line. Now, x1 plus 1 by, here the coefficient of x is 3 equals to, here y1 minus 5 by minus 2 equals to, here x1 minus 5y1 minus 26 by minus 13 equals to k. Assume like that, equals to k. Now x1 plus 1 by 3 is equal to k, x1 plus 1 equals to 3k. x1 is equal to 3k minus 1. Okay. Next. y1 minus 5 by minus 2 is equal to k. y1 minus 5 is equal minus 2k. y1 is equal minus 2k plus 5. Next. x1 minus 5y1 minus 26 by minus 13 equals to k. x1 minus 5y1 minus 26 equals to minus 13k. Now substituting these two. x1 that is 3k minus 1 minus 5. y1 minus 2k plus 5 minus 26 plus 13k equals to 0. 3k minus 1, here minus into minus plus, 10k minus 25 minus 26 plus 13k equals to 0. Here 3k plus 10k, 13k plus 13k, that is 26k. 3 plus 10, 13 plus 13, 26. Here minus 1, minus 25, minus 26, minus 26, minus 52. Okay, here k is equal to 26k is equal to 52, k is equal to 2. Now substituting the value of k here, x1 equals to 3k minus 1. 3 into 2 minus 1. 6 minus 1, 5. Next, y1 is equal to minus 2k, this one, plus 5, minus 2 into 2 plus 5, that is minus 4 plus 5. 5 minus 4, 1. Here coordinates of the point of contact are 5, 1. That is the answer. And the second method for this one is without applying this. Here to find the point of contact, it is the center of the circle. It is the tangent. To find the coordinates of the point of contact, here it is the foot of the perpendicular from the center to the line. It is the foot of the perpendicular from the center to the line. We know that formula. What is that? Foot of the perpendicular formula, h minus x1 by a is equal k minus y1 by b is equal minus of ax1 plus by1 plus c by a square plus b square. 2x plus y is equal to 0 is the equation of a diameter of the circle which touches the lines 4x minus 3y plus 10 is equal to 0 and 4x minus 3y minus 30 is equal to 0. The center and radius of the circle are. How to do this? Here, observe this. 4x minus 3y plus 10 is equal to 0 and 4x minus 3y minus 30 is equal to 0. These are parallel lines. These two are parallel lines. And these two are non-horizontal and non-vertical lines. But to understand the concept, I am taking the lines like this only. Like this. Actually, these two are non-horizontal lines. Next, here another line is given. It is the equation of the diameter. It means it passes through the center of the circle. This line passes through the center of the circle. Like this. Its equation is 2x plus y is equal to 0. Right. Now, finding the center and radius of this circle. How to do this? Here, these two are parallel lines. I am assuming this equation of this line is 4x minus 3y plus 10 is equal to 0. And second one is 4x minus 3y minus 30 is equal to 0. Okay. Like this. Now, this line is parallel to these two lines, and the middle line, it is equidistant from these two lines. It is the midline parallel to these two lines. It passes through the center of the circle. Here, point of intersection of these two lines is the center of the circle. We have to find that one. First, we have to find the equation to this middle line. Technique: 4x minus 3y plus c1 plus c2 by 2. c1 plus c2 by 2. It is the technique to find the middle line, like this. That is 4x minus 3y, 10 minus 30, minus 20, minus 20 by 2, minus 10 equals to 0. 10 minus 30 minus 20 by 2, minus 10 is equal to 0. Now we have to solve these two equations for the center of the circle. It is the center of the circle. It is the point of intersection of this line and this line. We have to solve these two. That is 4x minus 3y minus 10 is equal to 0. And the first equation is 2x plus y equals to 0. Solving these two. Here multiplying this equation, here 4x minus 3y equals to 10. Multiplying this equation by 3, this equation, that is 6x plus 3y equals to 0. Multiplying this equation by 3 minus, sorry, no need. Here adding these two. 4x plus 6x, 10x equals to 10. X is equal to 1. Substituting the value of x in this equation, that is 2x plus y equals to 0. 2 into 1 plus y equals to 0. Y is equal to minus 2. So coordinates of the center 1 comma minus 2. Okay. Coordinates of the center are 1 comma minus 2. Now, second question is finding the radius of the circle. How to do that? Here, perpendicular distance from the center to this line, or perpendicular distance from the center to this line, or distance between these two parallel lines, that is the diameter of the circle, by 2. That gives radius of the circle. Take the distance between these two parallel lines. That is formula mod c1 minus c2 by distance between these two parallel lines. That is c1 minus c2 by square root of a square plus b square. It is the diameter of the circle. Length of the diameter, this one. That is 10 minus C2, that is minus 30 by square root of a square plus b square, that is 4 square plus minus 3 whole square. 10 plus 10 minus into minus plus 10 plus 30 40, it is 5 8. It is the diameter of the circle. Radius half of this one is 4 units. Center is 1 comma minus 2 and radius is 4 units. The number of positions of P such that angle APB equals to 90 degrees and area of the triangle is 5 square units, where A is equal to 1 comma 2 and B is equal to 1 comma 6 is. Observe here 1 comma 2, 1 comma 6 abscissa are seen. Observe the points. Here 1 comma 2, 1 comma 6 abscissa are same. So they lie on a vertical line like this. 1 comma 2 and 1 comma 6. These are the given points. A 1 comma 2, B 1 comma 6. Here number of positions of P such that angle APB is equal to 90 degrees and the area of the triangle is 5 square units. How many possible positions for P? Here angle APB is equal to 90 degrees, so AB must be the diameter of the circle. Here P lies on the semicircle. To understand the concept, I am taking the figure like this. Suppose the points are like this, A and B. Here take the point P here. Angle APB is equal to 90 degrees. Take like this. First, distance between these 2 points. Distance between the given points. Observe here 1 comma 2, 1 comma 6. So it is 4 units. Diameter of the circle is 4 units. It means distance from here to here is 4 units. Radius is 2 units. Okay. Let this distance be h units. Area of the triangle formula, half into base into height. Half into base, that is 4 units, into height equals to 5 square units. It is given. So 2h is equal to 5. H is equal to 5 by 2, that is 2.5. Height of the triangle is 2.5. Radius of the circle is 2 units. Observe here. Height of the triangle is 2.5 with this. Radius of the circle is 2 units. So here P lies outside the circle. P lies outside the circle. In that case, angle APB is not equal to 90 degrees. It is not satisfying the given condition. So, number of possible positions for P is 0. Here the concept is here. See here. If the height equals to, height of the triangle equals to radius of the circle, the number of positions for P is either here or here. 2 cases like this. If height equals to radius, then the possible positions for P either here or here. It is the radius of the circle. It is also radius of the circle. Okay. If the height is less than r, if this height is less than r, in that case, we will get 4 positions for P. How? Take like this. It is the circle. It is the diameter of the circle. Height is less than r. Here, either here, like this. Second case, take like this. Here, this height is less than radius. This height is less than radius. And this height is also less than radius. But this point is on the circle. Angle in a semicircle is a right angle. And third case is taking the point here, like this. Or taking the point here, like this. So these are the possible positions 1, 2, 3, 4 for P. It is for H is less than R. For H is equal to R, these two cases. For H is greater than R. In that case, P lies outside the circle. In that case, the number of points for P is 0. If one of the diameters of the circle x square plus y square minus 2x minus 6y plus 6 is equal to 0 is a chord to the circle with center 2, 1, then the radius of the circle is, it is previous IIT question. Previous IIT question. Here, center of the required circle is 2, 1. It is 2, 1. Here, diameter of this circle is the chord of this circle. Diameter of this circle is the chord of this circle. Take like this. It is the chord to this circle and it is the diameter to this circle. It is the diameter to this circle and the same line is chord to this circle. Then finding the radius of this circle, that is the question. Here, center of this circle is x square plus y square minus 2x minus 6y plus 6 is equal to 0. Center of this circle is 1, 3. Radius. Radius of the circle is 2 units. Center 1, 3. Take like this. It is 2 units. It is the diameter of the given circle, this one. It is the center of this circle. Its radius is 2 units. It is the chord of this circle. Then the radius of this circle is, join like this. Perpendicular bisector of any chord passes through the center of the circle. So, distance between the 2 points. Distance between the 2 points, that is 2 minus 1 whole square plus 1 minus 3 whole square. 2 minus 1 whole square plus 1 minus 3 whole square. 1 plus 1 minus 3 minus 2 whole square 4. It is root 5. So the distance from here to here is root 5. Now join like this. It is the radius of this circle r. So r square is equal to, it is a right angled triangle. So r square is equal to this one. Take like this, a, b, it is m, It is C. Triangle AMC is a right angled triangle. In the triangle, AC square is equal to AM square plus CM square. It is 4 plus 5, 9. R is equal to 3. So the radius of the required circle is 3 units. If the tangent at P on the circle x square plus y square equals to a square cuts two parallel tangents of the circle at A and B, then PA into PB equals to, how to do this problem? X square plus y square equals to a square. Its center is 0, 0 and radius is a units. For our convenience, take the tangents like this. It is the diameter. The tangents at the ends of the diameter are parallel to each other. Here, take the point P here. For our convenience, take the point P here. Let the coordinates of this point, here the coordinates of this point are 0, A. It is x-axis, it is y-axis. The tangent at this point is the tangent at the point P intersecting the parallel tangents at A and B. Then PA into PB. It is 0, 0. Coordinates of this point 0, A. Here PA equals to the OM and PB equals to ON. Here PA equals to, it is the radius of the circle A. It is also A. Here PB, it equals to ON, that is also radius A. So PA into PB equals to PA into PB equals to A into A, that is equal to A square. That is the answer. If we take the point P like this, take the point here. It is the tangent at this point. It intersects these tangents at A and B. Then PA into PB. How to do this? Here, equation to this tangent. It is A, 0. Center is 0, 0. It is minus A, 0. It is parallel to y-axis. Equation to this line is x is equal to A. And equation to this tangent is x is equal to minus A. Here take the parametric point. Taking the parametric point, that is A cos theta, A sin theta. Equation to the tangent at this point and solving these two, do like that. That is the method. But this method is very, very easy. Try to apply this method only. Thank you very much.